Welcome, this is a CAD Image PLM demonstration of the Sheetmetal tools in Solid Edge. The topics for the session are to have a look at the interface, a brief introduction to some of the basics in Sheetmetal, then moving on to designing in context of an assembly and some of the different approaches that can be taken, and then on to flat patterns, generating drawings, a little bit of assembly work, so pulling some parts together, importing of files, 2D and 3D files, and generating Sheetmetal components from them, and then touch on rendering as well. So there's plenty for us to cover in this session. First up, let's have a look at the interface. So here we have the startup screen in Solid Edge with access to existing files, creation of new files, and a list of components that we have and assemblies that we have recently opened. On top of that, you have access to various blogs and community sites, Facebook type sites, social media type sites, and the tutorials and the learning tools in Solid Edge are available here on the left, on the right hand side. Let's have a look at some of the basics. To do that, we'll open up a Sheetmetal template, and this is the general layout of all of the environments in Solid Edge. So here we have a Sheetmetal file. We're presented with the coordinate system in the center that we can work off, a model structure, which is in this panel, dockable panel on the left hand side that can be moved and placed wherever the user prefers. We have a set of command bars where all of the standard tools for this particular file type are stored, and generally you find that on the Home tab you have all of the standard modeling tools or assembly tools. So here we can see all of the various Sheetmetal tools that I can use, set of drawing commands, dimensioning tools, etc. We also have some customizable areas in the interface as well. So there's a quick access toolbar across the top where we can place standard commands that I may use on a regular basis. So if we go to inspect, for example, if I go into this tool on a regular basis, if I'm using the measure command, for example, I may decide that I want to be able to add that to the quick access toolbar, so I no longer need to go to this tab to find that tool or any of the other tabs if I'm looking for tools on a regular basis. Most of the commands I'm going to end up running are in the Home tab, so now I don't need to worry about going to the Inspect one in order to be able to run this measure tool. On top of that, you have a Radial Menu as well, so holding the right mouse button down presents you with 16 buttons. Again, customizable area. You can add and remove buttons as desired, and the same goes for the rest of the areas of the interface as well. So this command ribbon, the buttons can be added and removed, and also changed from larger buttons, smaller buttons, add text, etc. The prompt bar, it can be docked as well, so we'll move that at the top of the screen. It's useful, I think, especially if you're a new user, to be able to reference that. There's lots of useful information that's presented to the user there to help guide you through feature creation, assembly creation, drawing creation, etc. There are two fundamental modes available to users of Solid Edge when it comes to part modeling and Sheetmetal design. They are called synchronous and ordered modeling. We'll touch on both of them as we go through the demonstration. We can see that this particular model is in synchronous mode, and the way that allows us to generate models, the order of creation or the way features are created, our users will typically go ahead and select a drawing tool, define a plane to draw on, then set some parameters. Once that element has been drawn, that the area inside the rectangle is a selectable area, and we can go ahead and generate some solid material from that. Material thickness is presented to us as an active input field. If we need to, we can go ahead and set the material as well, which we haven't done just yet. We'll have a look at that in a second. Sheetmetal lends itself to the synchronous modeling mode. Again, just a quick overview of how this can work. Once you've created an initial base plate, if I'm looking to bring some of the sides of this up to form some form of box or an enclosure, we can select the thickness faces, use the graphical inputs on the model to help generate some side faces. Again, I can select further faces. Again, I have graphical inputs that I can select from, having selected those thickness faces. And there are more little keyboard shortcuts as well. I'd like this particular flange that we're creating to be half the length of the first flange that we created off our base plate. So there are various little keyboard shortcuts that can help us do that as well. So they are all listed in the prompt bar. So a couple of little keyboard shortcuts, and we can very quickly create a flange that's half the length of the first one. And again, we can select additional thickness faces. The steering wheel can be moved around. We'll touch on how that works in a little bit more detail in due course. And we can generate further flanges. You can add dimensions or define sizes as you go, or you can add them retrospectively. So if I want to be able to control the length of that flange, we can always go ahead and grab our distance or dimensioning tools and go ahead and set a distance for that. And that is very much how the kind of sheet metal tools work. I'm not going to go into a huge great detail here. We'll perhaps touch on the detail tools in more detail as we go through this demonstration. So, but just a very quick enclosure. Not a lot of detail to it, but there's a lot more control available to us for things like corner conditions. So as you're adding features, you can define these corner conditions and bend conditions. We can retrospectively go and change those as well. So if I don't like the nature of the corners that we see there, I can go and add another feature to the model. And as we add features to the model, they are added to our model structure on the left-hand side. So just a bit of an overview of what the interface looks like, some of the names of some of the elements available to us, and a little bit of a look at quickly at some of the tools available to us as well. So we've covered a little bit on the interface there and some of the sheet metal basics. What we're going to have a look at now is designing in context. So a commonly used working practice in 3D CAD is to design in context. Let's close this model down and we'll go ahead and open up an assembly that's going to help show how this design in context works. So here we have a radio with some sheet metal components in it already. What I'd like to be able to do is just isolate the view of some of these components. So there's an enclosure that we've got to finish off. Let's go and isolate the view of some of those components. So this piece of sheet metal here is the one that we want to make some modifications to. And what I'm going to do a little bit later on is start something from scratch. Here we've got one of the designers has already come up with the initial features to the model, and I'm just going to add to those. And I can add to them without the need to edit down into the model. So again, just like we did in that first example, I'm able to go ahead and select thickness faces on the model and then use the input handles presented to me to go ahead and create some flanges. One thing we didn't touch on in great detail was any of the commands or any of the inputs that I can use to control how this flange is created. So I've got material conditions that I can define. We can define exactly where the measurement that we're creating on this flange can go as well. So where are we measuring from the bottom or inside face? Any key points I can snap to. And here's the options page where we can do a little bit more with regards to controlling some of those corners. So we had a quick look at that in that first example. But when you're creating flanges, you can define relief, and you can define bend relief and corner relief as well. This particular flange needs to be the same height as the first one that we've created, so we can very quickly select a couple of side thickness faces and generate a flange. And so this is being done cleverly from the assembly level without the need to edit down into the part. And so we can just make modifications to the part that way without the need to edit down to the part level. In the assembly, you also have the ability to create features, and there are some really useful controls here that we can use to define exactly where this feature I'm about to create is placed in terms of is it an assembly level cut, is it a part level cut, what nature of the cut is going to be. So lots of radio buttons here and lots of controls about how we're going to end up adding this feature to this model. I want to create a cut that goes on this side of the model, and we'll use some sketch geometry to do that. A slightly different approach to that first synchronous example we looked at. This is more of an ordered modelling example. If you're familiar with ordered modelling, this might be a slightly more familiar workflow to you. I'm just going to create a simple rectangle. I'm not going to add any dimensions to it because we're going to make some modifications to this cutout to make sure that it fits in with what we're trying to do here, what we're trying to achieve. And what I am trying to achieve here is just create some There are a number of fans inside this enclosure, and they need access to air, so we'll need to create a cut through the side of the model. Both sides of the model, in fact, and what I want to do with this last step is just ensure that we're creating a cut in this enclosure and nothing else in the assembly. So there are the fans that we've got inside the enclosure, and the cutout in itself actually is a little bit on the large side here. So what we can do is there's a couple of things we can do. We can clearly just make some changes. I can select the thickness face, and rather than creating a flange from it, I can just use the input arrow here and some key points on some of the other components in the assembly to help position this cut, or the sides of this cut, say relative to the features that are already in the assembly. So that's one way of doing things. Another thing that we might use, or another process that we might use here, is actually to use some face relationship tools as well. So here I want to be able to make sure that coplanar works, and what you could see there actually is some of the really helpful help tools and tooltips that Solid Edge incorporates, so that some of the more regularly used tools in Solid Edge have this enhanced tooltip. So not only does it tell you what that particular command does, but it also shows you a little video of that tool in working in practice. So say coplanar will work nicely here. Again, one of the thickness faces, if you can't select it straight away, commonly use CAD tool, this quick pick command, leave your mouse stationary for long enough and you can generate a short list of all of the elements that fell below where my mouse pointer was. That's the plane I want to be able to use, and I want to make sure it's coplanar with this element in the assembly. This face that's these fans are seated on. And I'm pretty happy with that cut. And to say all of this so far has been done without the need to edit down into the part, but it's probably not practical to do everything that we need to do. So at some stage, sooner or later, we will need to edit into this enclosure. Having done so, we can see some of the features that have been created. And in fact, that cutout isn't even listed at all here, and it doesn't need to be. If I need to add in any parameters, what we'll do actually, we'll just toggle off the view of the assembly. At this stage, if I wanted to parameterize this cutout, I could simply just grab a dimension tool, select a couple of edges, and place a dimension. That isn't what I want to do, but I could in theory do that if I needed to. One thing I'd like to do is drop down the height of this particular part of the side walls of this enclosure. So if I select that thickness face and start dropping these things down, what we'll find is that Solid Edge actually understands as all of the faces on top of this model, they're all coplanar. So Solid Edge is allowing us to modify all of those. That isn't really what I want. I'd like to be able to modify this side and also the flange on the other side of the model as well, but nothing else. So we can see the bar at the bottom is giving me feedback on exactly what's going on in the model here. And the fact is that the faces that are coplanar with the one that I selected are the ones that are being moved, and I can turn that off as a live rule, and then just go ahead and modify the location of the flange that I've got selected. And if there are any other live rules working on the model, then they may work as well. So we'll move that down. We'll move this face down, and again maybe just half the height of this the back flange there. So K on the keyboard, M on the keyboard will pick up a key point on the middle of that edge, and the flange is toggled and snapped to that point. Let's turn off the view of the rest of the assembly again, and I want to go ahead and add in a little bit more detail here on this side of the model. So we'll again pick up the thickness face, and we're going to generate a flange, but I don't want this flange to be across the entire length of that edge, so we just want a partial flange. I can also change the bend conditions here, or material conditions. I want the material inside, and you can see it's adding in the bend relief for us automatically. We can set a depth or a length for that feature, and if I need to, I can set an angle as well. 90 degrees is the default, and that works fine here. I would like some parameters on this flange, so we'll go ahead and add some dimensions. As soon as you place a dimension, you have full control over how that dimension can affect the model. So I want this this flange to be controlled symmetrically. I'd also like to lock it so that that dimension then is fixed in the model. I'm then going to add an extra dimension to the edge of the model as well. I'd like to line this up with the first dimension that we placed, and you can snap toggle that to our first dimension. Again, we can click and place that. Again, feedback to the user. This side face is the face that's going to end up moving if I alter this value. That's not what I want. I want the actual flange that we've just created to be moved, so we can change how that dimension is driving the model at any stage. Notice if I don't lock the dimension, it's presented to me or displayed in blue. If a dimension is locked, it is presented to the user in red. There's a sketch in here that will help generate some features on the top of this this flange that we've got. So I want to go ahead and add a hole perhaps. So we'll run the hole command from the radial menu, or you can pick the tools across the top. We can lock onto a face on the model, and then I can just use the center of that sketch. And in this case, actually, even though I've placed a hole, it is just a simple hole. The size isn't quite right. I could have changed it beforehand, but it's probably just as easy to do this after the fact, after you've placed it, because there isn't a huge difference in the size hole here. So I can very quickly, once I've placed a hole, change the diameter, and then once I've done that, we can go ahead and create a slot that goes in this flange as well. Again, that's why the sketch has been created. That slot needs to be fired down through the model. Again, there is an options page that you can use here to change the way this slot is being created. If that is a standard slot size, it would be a good idea either to save that as my default, so that all feature slots are created at a width of 4mm, or we can use some save settings up here if there are a number of different slot types that I create on a regular basis. The blue view, the blue colour is the indication or the preview of the feature. So until I confirm that what I see is what I want, I can always go back and change it. What we'd also like to do here perhaps is just break some of these corners as well, so we'll just soften some of those up. And I'd also like to just pull this flange just down a little bit. It just needs to be seated inside. Inside the top face of the model. In order to ensure that there is sufficient strength on this, we will add in some deform features. So this is where the Gusset Tool will come in useful. So again, we can select a bend on the model. It's useful here to have a look at the options page, and we can have a look at adding some rounding in here perhaps. And again, if that's more of a sort of standard setting for me, I might save this as my default. We'll also change the way that this particular feature is being added to the model. So I really want two of these, and I want them equally spaced. So if we change the gusset fitting and the count number, then you can see that it's previewing again in this blue colour exactly how that's going to be applied to the model. And right click will confirm that we're happy with that particular feature. If at any stage I need to turn off some of these dimensions, there aren't a huge number on the model, but sometimes they can interfere with what we're seeing. You can very quickly turn off the display of the dimensions. They will display, if I end up selecting a feature where there's dimensions attached to, they will display automatically, but then will be toggled off should we not need to see them again. Now that's all of those elements that we've just created on that side of the model. They need to be added to the other side of the model. Actually, just before we do that, I think what we're going to need to do is just pull this sidewall across. So we'll grab that thickness face, and again we'll just pull that across so it matches the cut on the other side. I don't think it was long enough to enable us to select all of those features, pick the mirror tool, and grab a reference plane in the middle of the model that allows us to pull that flange and slot and hole, etc., onto the other side of the model. Let's toggle the view of the rest of the parts back on. So we're making some progress here. What I do need to do on top of this, though, actually just to help us with this, it would be useful just to drop this down as well. So we'll pull this down, this side flange. And again, just half the length of that back flange is fine. So the next thing I want to have a look at is maybe just using a slightly more complex approach. And we've got a switch and a power socket on the back of this assembly, and we're going to change the design here. They're not going to be seated. They need to be recessed. They're not going to be seated on that back face. So in order to achieve that, what I'm going to do is I'm going to look to create the tool that's going to create that feature. So here we're going to have a look at doing a little bit of part modeling. So my initial design that we've got, this enclosure, we're going to call that the sheet metal part of this, and then the new element that we're going to create is the tool. So just to help clarify that in the interface, that's why I'm renaming these. So we'll add a part body, and then we will go ahead and use our existing sketch that somebody's kindly created for me, and we'll use that to go ahead and generate some solid material. So what I'm looking to do here is select the area inside the sketch lines that we've created, pick the vector that we want to use. It's moving symmetrically. Again, the prompt bar helps out a lot here, so you can see it says down there shift to toggle symmetry. So we'll toggle off the symmetry because I only want to extend this block in one direction, and 55 mils should do the trick with regards to distance. You can toggle the view of the rest of the parts on and off. So that looks okay as far as the tool's concerned. I do just need to add a little bit of draft angle in here as well, so we'll run some of that. We'll use one of the filters here just to reduce the number of clicks I need. I want to add draft all the way around the vertical faces. And we can quickly do that. And once we've done that, then we can run this emboss tool. So that's the tool that we're going to use to create this punch. And then we'll use the emboss tool. And again, prompt bar helpful here. The target body is the sheet metal body, and we can see in the model structure we've got a couple of bodies, the two that I created a little bit earlier, and then the tool body itself is the block that we created. Some of the options that we've got, we can include rounding or not. We can show we can define what happens once we've completed this feature as well with regards to the tool and the target bodies. And very quickly we can create that emboss feature. So now we've got a punched area where we can recess the button and the power socket as well. If we turn those back on, they're still not. There's no actual hole in this enclosure for those particular parts. So we should go and add in some of those as well. So we might use subtract here. That would help a lot. So again, target body is the sheet metal enclosure, and the tool bodies, we can select both of them, are the switch and the power socket. We can then turn the view of those parts off, and if I needed to add clearance, I'd probably just most easily do that just by adding in a dimension. So we'll pick a dimension. I want to be able to move the two sides of that cut symmetrically, and we can add in a minimal clearance there for those features. So we could go ahead and add in a few more dimensions and get clearance on all of those cuts for those parts that do fit in that area of the assembly. And that's an overview of some of the in-context design. So I did a little bit of in-context design with some of the early flange features, and then we've gone and edited down into the model and presented some of the sheet metal tools. Let's close and return back up to the top level assembly and say now our enclosure is a lot more useful than it was before, and we've got a lot more detail in there. So that's a look at some of the design in context features. I mentioned a little bit earlier that we're going to take a couple of examples there, and just before we move on to the flat pattern stuff, I'd like to open up another assembly. Excuse me. It's something that I've opened before, so we can go ahead and add it. We can go and pick it up from our regularly used list of files. You can see the green progress bar at the bottom there, so there are a number of controls in Solid Edge you can use to help load. If you're working with larger assemblies, then you've got some really useful controls to define how much information is loaded when you're opening up an assembly, how many of the components are displayed, and you can set that up to work kind of as last saved, or you can get Solid Edge to work off the number of components in an assembly. So a lot of useful tools, so for defining how long it takes and what nature an assembly open operation takes. Okay. So let's have a look at a second approach that we can take to designing in context. And it was a show only operation that I wanted there, because I just want to be able to isolate the view of the kind of the main components to this assembly so that we can focus in on the back here. And what we've got is there is a bracket here sheet metal bracket, and I don't have one on the other side. So what we're going to do is assume that we haven't got this bracket, because I could very easily just mirror that into a new component or new part file and place a copy of that on the other side of this assembly. But we're going to make the assumption that we don't have that part, perhaps. So at this stage, perhaps what we should do is we'll just turn it off. Actually, I'll leave it on for a second so we can kind of reference it and see how we get on. So let's have a look at this second approach. So here, this is sort of pure top-down modelling, designing in context. And in order to do this, I don't actually have the component that I want to create. It's not already in the assembly structure. I haven't got a piece part that's gonna that we're going to use to generate this. So I'm going to start from scratch, and we're going to create a new component. And I'm going to locate that component on the face that's highlighted there. And again, there are some really useful keyboard shortcuts that will help us position the steering wheel, and then also, sorry, not the steering wheel, the origin of this part file, and then also orient the coordinate system suitably as well. And again, lots of useful shortcut keys are listed in the prompt bar to help us with this. So it makes sense to locate our sheet metal component on that top face of this sort of suspension part that goes on this skid for this helicopter. We can also set the material at this stage. I can click the OK button, and then we can run off and generate our new part number. We'll save that. And the rest of the assembly has disappeared because the last time I was edited it into a part, and that was that enclosure in the radio, I'd switched the view of the rest of the parts off. So last used setting is remembered there, so we'll just toggle the view of the parts back on again. Okay. So here, the approach here is, rather than generating a load of sheet metal features from scratch, is if we look at it, actually I haven't even created a sheet metal file here. So that was that a mistake? Is that something that's going to cause a problem? Well, not really. The fact that this is a part file is neither here nor there. I can create sheet metal features. Ordinarily, it would have been a good idea for me to have told Solid Edge that I was creating a sheet metal file rather than a part file, but it isn't. It isn't a problem. And in fact, actually, it probably help us a little bit here, because what I want to be able to do is I want to be able to design a volume that the sheet metal file is going to fit inside. So it's helpful, again, perhaps to use one of these quick modelling tools. So we've defined a plane that I want to work on. We can snap the view of the model down onto that plane, and what we can also do then is start to use some of the geometry that's in the background here to help us define exactly how big this volume should be. So I've drawn the area that I want. Maybe I just want to be able to run this symmetrically as well. So again, the shift key works well there, and key points again on some of the background components are going to help to define exactly how big this box should be. And it's a decent start really. So for this part file is just to define an area. A block's a good start. So nice and quick to create that. Now that we've got that, it makes sense to just make some modifications and get some of these faces sitting on the assembly. Here's an example where synchronous technology, or the live rules that Solid Edge uses, is not quite what I want. I don't want to be able to move the front of this face and the back face, just the front face. So we can toggle off the use of live rules, and I just want to seat that back face onto the front face of this plate where this bracket goes. So that's one way of making that modification. Something else that we can then do is, again, using some of these face relationships. I had a quick look at the radial menu, but the face relate I was looking for wasn't in there, so we can just run it from the command ribbon at the top. A couple of clicks and we can get that face located, and that's not too bad. We're getting there already, actually. Something else I'd like to do is, rather than just selecting a face, is maybe just have a quick look at this steering wheel in a little bit more detail. So if I select a simple planar face, Solid Edge just gives me the ability to move that face up and down. If I then decide, actually, that's not what I want to be able to rotate this face. As soon as you select the little sphere, I'll drop out of that command again so we can see this. As soon as I select this sphere, it highlights in orange. I can relocate this steering wheel to different areas of the model, so corner points, edges, and depending on where I select and the element of the steering wheel I use, I can either move that face up and down, left and right, or I can use the torus here to help define or rotate this face over. And again, one of the really nice features in Synchronous technology is that it's not adding any complexity to the model. If we look at the features that have been created so far, it's still just a box. I haven't added 3 features just by selecting faces and dragging them around. There's no need to. It's just a box. It's just a slightly different shaped box than the one that we generated to start with. I do need to lop off the top of this box, so let's see how we might do that. Again, some of the geometry in the background here, some of the geometry in some of the other parts in the assembly is going to help us achieve this. So we'll use this projector sketch. The front face on the model will help us here. The little F3 lock symbol is also useful. And it's just that edge across the top of that sheet metal component in the background is the one that I really want to use. And again, Radial Menu is going to help here. We're going to run an extrude. What element do I want to be able to use for this extrude? It's not a face, it's just single or chain would work fine here, but I just need to be able to pick that single piece of geometry. And again, not particularly complicated. I want to create a cut using this bit of geometry. Which side of that line do I want to cut? Well, I want to chop the top of the model off, so I want the arrow pointing up. And at the moment, nothing's happening. What's going on? Again, the feedback to the user, it tells me no material addition. Well, I'm not trying to add material, I'm trying to remove material. So what's going on there? And then, in fact, if we look at the prompt bar at the bottom, space bar equals add cut. What will the space bar do then? Okay, it's going to toggle it from adding material to cutting material. That looks good. That's what I'm after. Click, and we have cut the top of the model off. Again, if I wanted to, I could start using some of these dimensions to help drive the model. I just don't need to do that. But that is the basic shape, to be fair. That's the basic volume that I'm interested in using to help generate this sheet metal file. A couple of features, and it's done. Now that we have got that shape, what we want to be able to do is convert it into a sheet metal file. So it's useful now to be able to switch across into the sheet metal environment. And again, I've added the button to the toolbars, but we can see now we've got access to all of our sheet metal commands. I also mentioned that, and most of the examples we've looked at so far are all in this synchronous technology, so which really lends itself very well to sheet metal. Very good in part as well, but the sort of nature of sheet metal parts, really good at that. The particular tool that I want to be able to use is sat amongst the ordered modelling. So a traditional history-based modelling system, most of the mainstream CAD systems fundamentally all work like this. They're very step-orientated, dependency-orientated. You create a sketch, you generate a model feature from that sketch. If you edit the sketch, the feature updates. And whilst that's very powerful, it also has some inherent complexities which can make models very difficult to edit when you start building accidental parent-child relationships, but that's a topic for another demonstration. What I'm interested in doing here is just converting this part into a sheet metal file. So if we kick this tool off, we've got some standard bend radiuses that we can apply. We can use the default value if I've assigned a material to this, or a gauge. In fact, we haven't looked at that. We'll touch on that in a second. Some corner conditions as well. So lots of control over how we're going to make modifications, how we're going to convert this block to a sheet metal file. We'll click on apply, and that means then I can go ahead and select edges on this volume and convert them to sheet metal flanges. Okay, and what we've also got, the ability now to change the model thickness. I can toggle this to inside to outside where the material thickness is going to be applied. If I move my model over or mouse over some of the corners, there's the bend radius that we can see in the little option page there is a global setting for this conversion. If I want to make some individual changes to some bends, that's what we can do here. But just by moving the mouse over the top of the bend and selecting the little icon appears, we've got relief options and bend radius options. If you select one of the individual corners, we can override the global corner changes here instead. So if I want to, I can change that to a circular cutout or any of the other standard corner conditions. And all those corner conditions are the ones that we'd ordinarily be able to select if we just ran the to bend corner command, which I hovered my mouse over a little bit earlier on. Once I'm happy with what the preview looks like, then we can go ahead and modify that. We can make that change. Now the model history doesn't quite look right here. We've got a box we've got to cut out and then it's convert to sheet metal, and for a kind of additional editing going forward, that isn't really going to do what I want to. And there's no real need to have this ordered feature, this convert to sheet metal. as a feature. I could go back and edit the inputs if I needed to go and add some more. I could do that, but I'm happy with the results. So I just want to pull all of that information across into the Synchronous environment. And you can see that it's actually added in tabs and flanges, recognisable sheet metal features. We can add in a few extra features as well. Again, selecting of thickness faces. Let's go ahead and do that. We'll grab those 3 thickness edges and material inside, bend outside. We might just add bend outside here, and we'll add a width to those. And I'm just going to add a couple onto the back here as well, so we can go ahead and attach this. We'll make some edit modifications at some future date, but the material condition is going to have to change here slightly because the volume that we created was butting up against the bracket that was on the main frame, and if I use bend outside, they're going to intersect, so material inside is going to work better here. And that's just going to require really that we just make 1 or 2 little edits. I don't really want these little bits at the back. We could use the steering wheel to make the modifications, but slightly more easy is to go ahead and just generate, or just go in and reorient the model and just delete the bits that we don't want. I don't really need to see those, so we can just select them and delete them. The alternative to that is to pick one of those thickness faces and then just use little key points on the model just to clear that away. So I can do that on one side. I could do the same thing on the other side, but actually, as long as Solid Edge can stitch the whole model together, it's probably just as easy just to go ahead and delete the bits that we don't want. So there is, if we turn the rest of the view of the assembly back on, that looks, barring 1 or 2 tweaks, I might just want to pull 1 or 2 of these faces down maybe, but we've seen how editing in context of the assembly, I can do that in the part, or I could go back to the assembly level and make that modification at a later date if I need to. One thing I will do is just soften up some of these corners as well. So break corner, fence select, should get most of them, if not all of them. Yeah, that looks a lot better. And looking at the bracket on the other side of the model as well, there's probably some holes and some additional cuts to go in here to lighten this part up. But we fundamentally got what we want. And that was really the approach that I wanted to show you, is that building of a volume and then converting into a sheet metal file. Really powerful stuff when it's, you know, generating some of these side flanges perhaps would have been a little bit more difficult to do if I tried to start from sheet metal in the sheet metal environment from scratch. Now I do want a drawing of this, because one of the elements we wanted to have a look at was flat patterning, so let's have a look at that now. And the way that flat patterns work in Solid Edge is that the developed or designed model and the flat pattern all exist in the same part file. So I can then follow the prompts and use the couple of buttons here. Again, this is a sort of standard function in Solid Edge for running commands, is as soon as this little bar pops up, there's an options page that you can use in sheet metal files, typically for controlling bend relief and corner relief, things like that. But what this bar is showing me is this is a 2-step process, this flat pattern tool. Step 1 is to select a face that will be effectively placed on the XY plane of the coordinate system we can see. That face makes sense to have that face coincident with that XY plane. And then step 2, click on an edge to define the x-axis and origin. And in this case, there's an edge to that face that we just selected. That one there makes sense, because what it's going to do is the little orange sphere that you can see is going to be located where the yellow sphere of the base coordinate system is, and then the edge is going to be aligned coincident with the x-axis. So if we click, you can see there's that origin point, and the edge is now parallel and sort of coincident, collinear with the x-axis. So now our model contains the synchronous developed model and the flat pattern automatically presents information to us, blank sizes primarily. If you need to, if I need to go ahead and add some design information here, because we know that we're going to need to add a tab in here to fix this while we make it, then I can always go and run the tab tool if I want to. We've also got some additional controls. Cut sizes, you can set an alarm up if the blank size is going to be bigger than the material that we've got. We've also got a lot of controls over corner treatments, inside corner treatments, outside corner treatments, additional elements that might be added to the flat pattern to help manufacture. We'll go ahead and save this file. If I need to go back to the developed model so that I can start or continue with our design, you can simply click back on the synchronous mode that we've got listed in our model structure, and it's folded the model back up, and I can carry on making some modifications to this. So that's flat pattern dealt with. I want to go ahead and create a drawing of this, then that would make sense, so we can go ahead and make it. There's a couple of things you can do actually here to go ahead and set this model up so that we can manufacture from it. I can just save straight out from the solid model to a DXF file, perhaps, which is an option. The other option that I do have is just to go ahead and run the drawing tools directly from the model. So any 3D solid model in Solid Edge, we can run the drawing tools from. Here's our standard drawing template. Initially, the model is displaying with the folded state. That's not what I want, so we want to go ahead, pick up the options page, and pick the flat pan instead. That's not the view orientation that I want, so we'll probably want a top view. Top view is going to be looking down the Z-axis from the model perspective, from the model point of view. That is pretty much what we want. We've got some options in here to control the scale if I don't like that. Custom scales. You can also go ahead and added shaded views as well. I think what we might do here is just drop down the view of the model, and then we might just run that view wizard again. So it's the same model. I just like to be able to put an isometric or trimetric view of the model on, so that the guys on the shop floor know what the model looks like when they finish making it, and we can drop that in the corner here perhaps. What we do have is, let's just have a look at we'll have a look at some of the dimensioning tools in a second. Let's just have a look at the drawing border. So at the moment, here's the part number we defined. The material's been pulled across, as has the weight as well. So that information got calculated automatically. The initial drawing view scale has been added. A couple of things that haven't been added here, title and issue. So it would be useful. Let's go ahead and save this drawing into our project folder, and that should certainly sort out and it's added or modified the drawing number. It's also put the date in. Andy Rigby was added in automatically as well, so it's just using my Windows login name there by default. Some of these other properties are missing. I'd like to go ahead and add in a title and an issue, so let's do that. I could edit into the model. Let's have a look at another way we might approach that though. Property Manager is a really useful tool, especially if you're working in bills and materials where there's a number of files that have missing information in them. So Property Manager just gives you access to the file properties that all Solid Edge files have without having to go into the time-consuming process of editing into the model to make the changes. So here we've got title, so the part file itself, that needs to be skid suspension bracket. That's what we're going to call it. And the issue, so the revision, is going to be A. Click on OK, and what the Property Manager is doing is it's physically writing that information down to the part level properties. And that has got all the information now in the drawing border that we require. So set of my material, that's looking good. Let's have a look at some of the dimensioning tools. So here I might just pick up distance between again, one of those really useful tool tips for new users, and I just want to be able to dimension up the bends on this particular view. And we're going to pick up some a stacked dimension to help us with that. If you don't like the accuracy, we can always go ahead and select the dimensions. All the dimensions have a number of different styles, but if I just need to make some on-the-fly changes, that's very easy to achieve. So a nice tool there that will enable us to pick up all the dimensions very quickly, and then some controls in this command bar that will allow us to make those changes. I would like to know a little bit more about the bend order to this model. So what I'm going to do is, what I've tried to do there is double click, because double click on a drawing view will open the model, and the prompt there is, well, actually the model is already open, so you don't need to go ahead and open it, and we can toggle across to that model through the command ribbon. So now that we've got the Sheetmetal file back open again in the Tools tab, we've got a bend table that we can use, and the bend order is worked out for us automatically, but we can always override that. Actually, number 3, that one is supposed to be the first bend in the model, and we can move that up. Click on OK. We'll save the model, what impact has that had on the drawing? Quickly toggle across into the drawing, and nothing at the moment. That's only because I haven't put a bend table on. So we'll add a bend table from that model. We'll drop the view down, and we can update the views so that we can get the numbers up to date. So initially, Solid Edge was taking the bend order there from the view that we created to start with, but we can update that so that the bend at the front there is number 1. Editing of the bend table. It's pretty straightforward. You can double click and then it really just works like an Excel spreadsheet. So we can make some simple text changes and change some of these values, whether or not you edit it into the bend table or not. And we can maybe just overlap that with our drawing border as well. If I was after a little bit more information with regards to individually perhaps labeling some of these bends as well, then we might look to use something like a call-out tool. So here we can use this to go ahead and automatically give us things like bend radius. So go ahead and get bend radius from the model. That's what this call-out tool is going to do now. Actually, it was the bend angle I was really interested in. Actually, let's just put another bend radius on there. Okay, so there's some differences there in bend radius, and we'll go back into the properties page here. And I'm interested in bend angle. Click on OK, and so typically most of these are all going to be 90 degrees, but that particular one is not 68, but the rest of these are all 90. So a little bit of a look at some of the dimensioning tools. So we looked at Smart Dimension when it came to the solid model itself, but we used a slightly different dimensioning tools just to run those dimensions across the top. So that's flat patterns and drawings. Let's have a look at some of the assembly stuff as well. So we haven't really looked at kind of constructing assemblies. We'll run a simple example here, so we'll close and return. And what I'm going to do now is we will go ahead and just again show only this assembly. And what I want to be able to do here maybe is just grab this part and just pretend that we haven't got it. So we'll turn it off. And then just to show kind of how the assembly construction tools work, I drag in my part. There's a number of different ways that you can do that. But typically, you're going to place the component that's supposed to go in the assembly. It will place it where you drop it, and then it's simply a case of selecting faces on the model to get that model in the right location. So I want to be able to line up that side face with, at the moment the model in the background isn't highlighting, so this is one of those scenarios I mentioned earlier on where Solid Edge has done a job of allowing me to open the assembly quickly without loading all the information about all the parts. So that particular part, well, I wasn't able to select that face a second ago. Wrong face, we'll use Quick Pick perhaps. I've loaded the information about that part file into memory, so initially it wasn't selectable because Solid Edge hadn't done that, so that's why I was able to load up the assembly a little bit quicker than I perhaps would normally. And finally we're going to seat the thickness face onto that plate that's already in the superstructure for the helicopter. And that's how creating assemblies works. And the example I've shown there is a typical one really. It's a lot of selecting of faces so that they're mated, aligning faces and lining holes, and all of those can be achieved by kicking off this assemble tool either manually or when you drag a component in, Solid Edge will automatically kick off this assemble tool. That's what happened when I dragged that bracket in. Solid Edge went and kicked off the assemble tool, and again the tooltip there is doing a nice job of showing us exactly how that assemble tool can be used for creating axial alignments, planar alignments and mates. If I decide that we'll go ahead and perhaps select this component, we'll drop out of the positioning process. So these are the three relationships that we just selected, and again Solid Edge does a really nice job here of just allowing you to isolate the view of those. So if we go ahead and select a number of different relationships, you can see that Solid Edge is isolating the view of the component or relationship that I got selected, and the component that it relates to. It fades everything else out. So that first mate related to this top component in this little suspension assembly, the other ones were related to the part, the black part. So that's a little bit on assemblies. Let's have a look at how we might import a file and what we can do with an imported file. So we'll go to File and Open, and we'll go ahead and find something. So here, this particular example, say, is a SolidWorks enclosure part. So we'll go ahead and open it. Makes sense to put it into a sheet metal file template, so we'll do that. And initially, it opens up as a single lump solid with a fairly garish colour. So step one might be here to change the colour. We'll use the part painter tool just to change that to aluminium. We could perhaps do the same thing through the material table. I mentioned the material table. I was going to have a look at it. Let's go and have a look at it now, perhaps. So materials, we can assign recent materials. There's our favourite materials. I really want to have a look at the material table as a whole. So we can open it up. We can assign the material. We can assign what that material looks like in Solid Edge, and also what it will look like if we decide to go and do some rendering. Gauge properties, a standard list of gauges. We can set up and read from an Excel spreadsheet, which may have a number of different materials set to it. So depending on the material, bend radiuses and neutral factors, etc., might be slightly different. Let's apply those changes to the model. And so initially, really what we've got here is just a lump solid. There doesn't seem to be a lot we can do with it, but there is quite a bit that we can do with it. So if we're looking to, I actually want to convert this into a sheet metal file. So we'll go into the tools, and we'll go ahead and convert this to a sheet metal file. And again, that process has worked nicely. All of the flanges and tabs have been created. So now that we've done that, what can I do with this file? Is it editable? Well, so the fact there are no dimensions on it is neither here nor there. I can fence select areas that I want to make modifications to. We can pull that out. If I need to select individual faces and move them up, I can do that. So actually this particular element here needs to be moved up, and actually all of the faces that are coplanar need to be moved as well, and Solid Edge is able to recognise those. I've just turned that coplanar rule back on because it was off initially, and you can use keyboard shortcuts to do that. The keyboard shortcut you can get from the tooltip. That whole thing needs to be shifted up by a couple of mil. The holes in the model are not really very helpful, or are they? Well, they'll give us a diameter, so I can go ahead and actually 3 point, yeah, that's an odd one. That one's supposed to be 40. If I want to, if we go to the Home tab, we've got some really useful tools here we can use to recognise all of the different holes. So if we go ahead and we're looking at the whole model here, so there are a number of different hole types, instance counts, etc. So we'll click on OK and convert all of the cuts that are just circular cuts in the model to holes. And then what we also might do is recognise hole patterns as well. And there's what I'm going to do is I'm just going to recognise the ones at the back here. So we'll fence select those. Can Solid Edge go and recognise those as a number of patterns? Well, it can. What pattern type is it? Is it a rectangular or circular pattern? Do I want to recognise that? Actually, if I'm not interested in recognising that as a pattern, we can turn it off. I am, but that does at least give us the PCD values, so we can change that if we want to. That's supposed to be 50. And it's also supposed to change this to a pattern of 12 as well, because that pattern count's not right. So the fact that I didn't create this, we can also add in dimensions. So if I want to go ahead and make changes to this cut that's in the end of the model here, again we can drop a dimension on that. I want to be able to move that symmetrically, and we know that that's supposed to be 150. It's located right, but the width is incorrect for our design purposes, and do something similar perhaps with the height as well. That height's supposed to be 40 in our new design. And without having to do too much, I can very quickly convert that into a usable model, and it might almost be easier to do this in Solid Edge than it was to do it in SolidWorks. So I can add as much or as little control into this model as I like, but very quick and easy to create or convert a sheet metal file into a Solid Edge usable sheet metal file. You can also use 2D files as well, so let's have a look at how that might work. open up, there's a DXF file. Let's open that up. It opens into a open it into a drawing file would make sense here. So there's some information in here, so that would be helpful perhaps for us to go ahead and create a sheet metal component. So I don't really need, if I select the elements that are in this imported file, it tells me exactly which layer that's appeared on, and I can hide it. I only really want this geometry here, so we can turn the rest of it off, and we'll just grab that stuff, hide that as well. And is that everything I need? I'd like the bracket and I'd like the dimensions. That looks pretty good. So what I want to be able to do is then pull this information across into a sheet metal file. So we'll run this create 3D tool, which does exactly this. It allows us to take information from a DXF or a DWG file typically and add it to a part file or a sheet metal file or an assembly. Makes sense for this to be a sheet metal file. Once I've defined exactly which file type it is that I'm interested in adding this information to, we can then go ahead and fence select all of the various views that we want to use on this file. Let's just make sure we've got that. Create 3D. Yep, happy with the template. We'll grab that as one view that I want to be able to pull across. I want to be able to use that as a second view that I want to pull across, and that as a third view. And we'll finish that. So then that information is pulled across as a number of distinct sketches that we can use in our sheet metal file. Makes sense to create a tab first of all, so chain of information, all of those edges I want to go ahead and create a tab from, and in this case the material thickness. I think it says it's somewhere in there, but if we do a right view, that looks kind of right. Useful to have some of these dimensions, so even though useful to have some of these dimensions. So slightly different approach here perhaps to what we were doing before. I would like to be able to add in some jogs. So there's a jog that goes in that side of the model, and we can again use information in the model in these sketches to help define exactly where that goes. And then there's a second jog as well, so we'll run another jog using that edge there, that side of the model, and we can drag it down to there. And then what I might do is we go ahead and add in some holes. So there's some holes that go in here. We'll lock onto that front face. Again, the sketch geometry that we've already got would be helpful here. And it looks like I'm going to need to change the parameters of these holes before we move on. So let's go ahead into the options page. Extensive options, number of different hole types, standards, drill size, the fit as well. So I think in this case it's probably more like 4. I think if Solid Edge doesn't like that, it's okay. Let's add those in. We can always go and make modifications to the size afterwards. So actually if it's still a bit too big, just as easy to make changes. Oh, wrong way, and they're too small. If you need to, you can turn off the sketches, and we can turn all of these other elements off just to turn all the sketch information off, and I can go ahead and add in the missing holes, add in a few of the break corners, run the flat pattern tool, and pretty much recreate the drawing that we've just generated this information from. So whether or not your existing CAD information is in 2D or 3D makes very little difference to Solid Edge. Let's just touch on rendering and finish this session off. So we'll go back to our initial assembly, and we'll turn all the bits and pieces on. Let's turn all the parts on and get this into a suitable orientation. So that sort of orientation there looks pretty good, and at this stage then we'll fire this across into key shots. So if you're looking at Solid Edge Classic or Premium, then this is what it includes, is this key shot product, which is a high powered rendering tool. Really sort of market leader in this area, and a very powerful tool. Contains an excellent rendering engine and also a whole raft of materials. So initially the renderer will take whatever material you've assigned to Solid Edge and convert it to a material that it recognizes. If you don't like that or you want to make some changes, it's simply a case of grabbing the material that you want from this material list, and dragging and dropping it onto the model. If you need to change the orientation, I can quickly rotate it around, and there's lots of controls that allow you to define exactly how and when renders occur, but typically out of the box, as soon as I release the mouse, KeyShot will look to go ahead and render that up as a result. There are various colours that you can add if it's a simple colour change, lighting effects, backgrounds. I don't think any of all of these backgrounds tend to be kind of outdoors or old broken down manufacturing plants, so perhaps not relevant to this, but very powerful rendering tool capability now with Solid Edge. If I make some modifications to this, one of the tools that I really like is, okay, so if I went and modified the enclosure and we put the top on this thing, what I can do back in Solid Edge is just update KeyShot. So I might have made a load of changes to that. I don't want to have to go and import it all over again and make modifications all over again. I can very quickly update KeyShot with the changes that I've made in Solid Edge. So powerful stuff. And that is an overview of how Sheetmetal works in Solid Edge. I hope you found this demonstration